Hello everyone, welcome to the video explanation for Brian Passwater's topic 2.4 notes. Example 2. Example 2 has an important idea attached to it, and that is that every horizontal translation of an exponential function in the form f of x equals b to the x plus h, that should be an h, kind of looks like an n, but it's supposed to be an h, is equivalent to a vertical dilation of the exponential function f of x equals a times b to the x, where a is equal to b to the h power. So what we're going to do is, here in example 2, we're going to take each of the following exponential functions that have a horizontal translation, and we are going to write an equivalent representation of that function that, instead of having a horizontal translation, it has a vertical dilation. And we're going to do that using exponent rules. And the exponent rule that we're going to use is that if we have two bases being raised to different, or the same base being raised to two different powers, the product rule says that if I multiply those together, I would add the exponents. We can also do that in reverse. So when we look at letter A, and it says f of x equals 2 to the x plus 2 to the third, we should remember that that means that is 2 to the x times 2 to the third power. Well, 2 to the third power is a constant. That is 8. So we'll move that over here and call it 8. And then we just bring down the 2 to the x power, and bam, we've got ourselves a function that has a vertical dilation without a horizontal translation. So let's do that again for the next one, for g of x. So for g of x, again, if we have those, remember that x minus 2 is the same as plus negative 2. As a result, we can write that as 3 to the x times 3 to the negative second power. We should remember that 3 to the negative second power, a negative exponent, is nothing more than 1 over a positive exponent. So we can rewrite this as 1 over 9, 1/9, times 3 to the x power, which again has a vertical dilation of factor 1/9 and no horizontal translation. Finally, for k of x. Now this one is a little bit trickier because there is a 4 sitting in front of it, but we basically just ignore that 4 to start with. We leave it there, and we take the 3 to the x plus 2 and we rewrite it as 3 to the x and 3 squared. Now I am going to switch the order of those, which I can do using the associative property of multiplication. It does not matter which order I multiply things in, because we can then do 3 squared, which is 9, and then we can do 4 times 9 to get 36 times 3 to the x power. Again, that is an equivalent exponential which has a vertical dilation and no horizontal translation. That does it for example 2.